Hello everyone, today we'll be exploring and going over interrupts and operating systems, and we will be going over what they are and what they do and just how useful they are and the important tasks and roles they provide. So let's continue and let's start. Alright, so our first topic is what are interrupts? How's the role of an interrupt? How does it operate? Well, interrupts help the CPU handle multiple tasks efficiently by allowing it to respond to urgent events such as the user input, the hardware request, or system errors without having to constantly check for them. And so how do they operate? So when an interrupt occurs, the CPU pauses its current task, saves its state, and executes the interrupt handler. Once the interrupt is processed, the CPU resumes its previous task, ensuring that it's smooth and that it's responsive to the system performance. Okay, so now we are on our next topic, which is hardware interrupts. What is a hardware interrupt? Well, a hardware interrupt is a signal from hardware, for example, a keyboard, a mouse, and notifies the CPU of an event that needs immediate attention. And next we have examples of it, such as a maskable interrupt, short for MI. So this means that it can be ignored or delayed by the CPU if needed, and is often used for regular hardware requests. And next we have a non-maskable interrupt, so NMI. And this means that it cannot be ignored and it's used for critical system events like hardware failures. Okay, so our last topic was hardware interrupts. Now we'll be looking at software interrupts. So what is a software interrupt? Well, it is an interrupt triggered by a software instruction rather than hardware, and it's often used for system calls. And during the software interrupt, we have different examples, such as a normal interrupt. So this is generated intentionally by a program to request operating services, for example, input-output operations. And then next we have an exception. And an exception is an unexpected interrupt caused by errors like division by zero or an invalid memory access, causing it to fail. Here in this slide, we have a diagram representing both cases of what happens in an interrupt and either hardware or software. We see with how each specific action is taken. If there is an issue, it will be separated to either case, for if it is a hardware interrupt or a software interrupt, and we'll derive from both of these instances. So next we have managing concurrent processes and ensuring system responsiveness. So this ensures that multiple programs run efficiently without slowing down the system and ensuring that the system responsiveness allows the operating system to quickly handle user inputs and critical tasks, preventing freezes or delays. Okay, and with that we have reached the end to our slides. I just want to say thank you for watching. I hope I've given you some insight into the world of interrupts and how they operate in operating systems and just how we can define interrupts. Please feel free to like, share, subscribe, comment, and I will see you in the next video where we will be discussing more about interrupts, just exactly what they do, some other types of examples that can occur in interrupts, and just how it affects the operating system and the type of issues we can see when it runs into them. Alright, but other than that, thank you for watching and have a good one.